Hi everyone. Most recently, AI agents becoming more and more important part of our life. And although there are many types of large language models out there, including multi-modal large language models, still at this stage of agentic AI applications, mostly used large language models are the ones which generate text. In this video, I would like to show how we can create voice agent, which will process real-time speech from the user and will produce real-time speech by the agent back. To implement these voice conversational agents, I will use AWS Strands Toolkit, and we will create a bidirectional streaming agent for real-time audio and text conversations. We will learn how to set up audio, handle streaming events, and use tools during the conversations, as well as working with different model providers. That said, I will mention few prerequisites you should complete before implementing the following examples. So first of all, you should have AWS Strands installed, and also you have to install the bidirectional part of the package. Secondly, you have to set up your AWS access key ID and AWS secret access key together with the region. This should be predefined through your AWS CLI console and set as environmental variables in your operation system. Let's create our first conversational voice agent using AWS Strands. Since most of the events should follow the asynchronous processing, we will have to import async.io. Then we import Strands experimental bidirectional, and from here we import bidirectional agent and bidirectional audio input and output. Finally, as in the case of standard text generating agents, we need to use the large language model. In this case, this will be large language model containing two modalities, text generation and audio generation. For this, we import from Strands experimental BD models, BD Nova Sonic model. So Nova Sonic is the key model which will help us to implement the voice conversational agent. So next we define the model as bidirectional Nova Sonic model. We defined bidirectional agent where they use model as model and system prompt UI helpful assistant. Next, we have to define our audio input and output using BD audio. And then we create a helper function in asynchronous manner where we say that we start our conversation and we actually run the agent. So the inputs into the agent will be the audio input output input. The inputs into the agents will come from audio IO input, and the outputs of the agent will be coming from the audio IO output. Finally, we will run our main function. So let's run this file. Okay, so the agent has started now, and I will ask the agent, hi there.
Hi there. It's great to hear from you. How can I assist you today? Whether you needed help with a question, some advice, or just want to chat, I'm here for you.
What is the capital of the United States of America?
The capital of the United States of America is Washington, D.C. It's a fascinating city with a lot of history and important landmarks. If you ever get a chance to visit, there's so much to see and do. Enjoy your day.
Thank you. Okay, so now I have interrupted the conversation with the agent simply by clicking Ctrl+C. And we can have this ugly keyboard interruption. One thing what we can do is try to fix the conversation control and add some exceptions around the agent running flow. And in this case, we will add some exception of async IO cancelled error. And also we will stop the agent after all the interruptions or exceptions caught. So this is our main update to the code. Let's run this updated agent with conversation control. Let me clear the screen first. And now let me add conversation control. Hi there.
Hello. It's great to hear from you. How's your day going so far?
That's okay. What is the capital of the United States of America?
The capital of the United States of America is Washington, D.C. It's a fascinating city with lots of history and landmarks to explore.
Okay, thank you. So now then I'm interrupting conversation with the agent. By Control C, we are notified that conversation canceled by the user. Okay, at this point we are having fun having a chat with the conversational voice agent, which is enabled by Nova Sonic model by AWS. But one shortcoming of the current interaction is we are not actually able to see in a text format the inputs and outputs, which are being pronounced as a speech. So let's fix this now by adding additional piece of code. So to control the text input output, we need to import bidirectional text IO, or simply BD text IO, from Strands experimental BD IO. Then, similar to audio IO, we have to define text IO by instantiating the object BD text IO. And now we will have to add text IO input to the agent input and text IO output to the agent output. And this is exactly the power of the multi-modal large language models. In this case, both text and speech will be generated by Nova Sonic model. Okay, let's clear the console and run this example. Hi there.
Hello. It's great to hear from you. How's your day going so far?
I'm okay. What is the capital of the United States of America?
The capital of the United States of America is Washington, D.C. It's a fascinating city with a lot of history and landmarks. Is there anything specific you'd like to know about it?
No, that is okay. Thank you.
You're welcome. If you ever have more questions, whether they're about history, facts, or anything else, feel free to ask. Enjoy your day.
All right. And here we actually encountered some problem, as we previously were able to catch the asynchronous cancellation error. Right now, even though I generalized the catch to any exception, it is not really capable of catching that and providing this nice message. Instead, it's saying we are treating Python exception as the error. So that's worth keeping in mind while designing this try except things which appears to be not so straightforward and easy. Let me click Control C again. Now finally we can see that the conversation has been cancelled and we have tons of traceback files where a lot of things happened behind the scenes and where the error had occurred. So far, we have designed the bidirectional voice conversation agent. We enabled also the text visualization while providing inputs to the agent as well as getting the output from the agent, which are generated by the bidirectional Nova Sonic model. However, the power of the agents, not only using the large language model per se, but also using the tools of different kinds. So in the next example, I will add the tools, and we will see how conversational voice agent is capable of using the tools as standard text processing agents do. So in order to be able to use the tools, I will import from Strands. This module is used to define the decorator to enable my custom tools to be designed. In this case, I create function getWeather, and this is a simple function which is basically getting the location and generates the weather in the location is sunny and 72 degrees Fahrenheit. So in order to make this standard Python function a tool recognized by AWS Strands agent, we need a tool. We need atmap tool decorator. In parallel with the custom tool, from Strands tools, I will import calculator tool and current time tool, which are out-of-the-box tools provided by the AWS Strands SDK. So in total, we will add 3 tools to our agent: the calculator tool, the current time tool, and getWeather tool. And I update the system prompt, now saying you are a helpful assistant with access to tools. The rest of the code stays the same. So now let's run this example and see if agent can use the tools. Hi there.
Hello, it's great to hear from you. How's your day going so far?
What is the weather in Washington, D.C.?
The weather in Washington, D.C. is sunny and 72 degrees Fahrenheit. Sounds like a lovely day to be out and about.
What is the current time in Washington, D.C.?
The current time in Washington, D.C. is 10:52 p.m. on May 5th, 2026.
Okay, can you please sum 10 and 15 for me?
Sure thing. The sum of 10 and 15 is 25.
Could you please also compute log base 2 of 8?
Absolutely. The base 2 logarithm of 8 is 3.
Thank you. Okay, in this example, we can confirm that the weather tool has been used as agent provided the expected output of location, which was Washington, D.C., and saying weather in Washington, D.C. is sunny and 72 degrees Fahrenheit. Then I asked agent about the current time in Washington, D.C., and it replied 10:52 p.m. on May 5th, 2026. Finally, I asked agent to perform 2 mathematical operations, basically adding up 10 and 15, and the result was given as 25 correctly. And next I came up with a little bit more complex computation of computing log base 2 of 8, and the result was 3. So in this case, we can see that agent was able to use the tools, and we have a successful implementation of the AWS bidirectional streaming voice agent powered by the bidirectional Nova Sonic model. Now, let us have a look what other models can be used for the same task. At this point, AWS Strands notifies that 3 models are supported. So first of all, it's a Nova Sonic model. which is bidirectional streaming model via AWS Bedrock. That's exactly the model we have been using extensively so far. Next is the OpenAI real-time model and Gemini Live. So now let's try to use both models and see what would be the performance and the outcomes. So first, let me show the code for the bidirectional OpenAI real-time model. We will import BD OpenAI real-time model from Strands experimental BD models, and this will be our new model. However, in order to use this OpenAI model, we will need OpenAI API key. So to do so, I will import OS module. I will also import load.env from .env, and I will run the load.env file. So next, I will actually read the OpenAI API key from .env file. And then I will define a model, which will be my BD OpenAI real-time model. The model ID will be GPT-realtime. As a voice, I will use a Coral, and as a client config, I will provide OpenAI API key. Everything else stays the same. The same tools, the same inputs and outputs. Now let's try to use different model in AWS Strands voice agent. Hi there.
Hi, how can I help you today?
What is your name?
I don't really have a personal name, but you can call me Assistant. I'm here to help with whatever you need.
Which company designed you?
I was created by a team at OpenAI, a research and development company that focuses on artificial intelligence. They're dedicated to building helpful and safe AI systems.
What is the current weather in Washington, D.C.?
The current weather in Washington, D.C. is sunny, with a temperature of about 72 degrees Fahrenheit.
What is the current time in Washington, D.C.?
The current time in Washington, D.C. is 10:57 p.m.
Can you please sum 10 and 15?
The sum of 10 and 15 is 25.
What would be the result of log base 2 of 8?
The result of log base 2 of 8 is 3.
Okay, thank you.
You're welcome. If you have any more questions, feel free to ask.
Okay, I have interrupted the agent here. So far, we can see how different models are basically producing the text output. But as for the tasks to use the tools, we have also successful performance. So we can see that the current value in Washington, D.C. is sunny with a temperature of 75 degrees Fahrenheit. That current time in Washington, D.C. is 10:57 p.m. and that the sum of 10 and 15 is 25, and the log base 2 of 8 is 3. So we can confirm we are correctly using the tools. And that's basically a successful implementation of the OpenAI bidirectional streaming model as well. Now, let us run the third model, which is Gemini Live, which is a Google multi-modal streaming API. To do so, I will have to slightly modify the code again. So first of all, I will be using BD Gemini Live model imported from Strands experimental BD models. Next, I will need my Google API key, As per model, I will define the model using a BD Gemini live model. In this case, model name will be Gemini 2.5 Flash Native Audio Preview 09 2025. And I will choose voice of Corey. And as a client config, I will provide my Google API key. And this is the main modification to the code here. So let us start the voice agent, which is powered by the Gemini model. Hi there.
Hi, how can I help you today?
What is your name?
My name is Gemini.
Who developed you?
I was developed by Google.
What is the capital of the United States of America?
The capital of the United States of America is Washington, D.C.
What is the current weather in Washington, D.C.? Okay, and here is one of the problems I have found with current out-of-the-box implementation of Gemini models. Right now, whenever you keep the conversation with Gemini model without using tools, it goes okay. However, once you try to use the tool, the Gemini model halts. So this is the current status of using the Gemini model. So out of the free models, which are currently suggested by AWS Strands team, basically the fully working models are Nova Sonic and OpenAI real-time. Okay, so this example basically concludes all the examples with voice agents. Let me do a quick recap. So first of all, we have defined very simple voice agent using the basic set of BD agent and BD audio input and output, which enabled us to deploy very simple voice conversation agent. Then we tried to put the control over the conversation flow. Then we have introduced the BD text IO, which allowed us to print out inputs and output of the text, where not on together with the speech, together with the audio. And then we have defined and used the tools. Then we have defined the tools, one custom tool to return information about the weather in the current location, and two out-of-the-box tools, which are calculated in the current time. And all these examples were done using bidirectional Nova Sonic model from AWS Bedrock. Finally, we have used two more different models, the one provided by OpenAI and the one provided by Google. And what we have found out that the model provided by OpenAI is fully functional and is capable of using the tools, both custom tools and out-of-the-box tools provided by AWS Strands Agent. However, once we switch to the Gemini model, we were not able to use the tool. And basically, once the tools are called, the agent is halting or shutting down, generating the error. So thank you very much. Consider to like this video and subscribe if you find this information useful. You can see all the codes also in the GitHub in the description below. Thank you very much, and stay tuned for more videos about the agents. Thank you.